Hello students, happy morning. Class 12 Physics, Unit 6 Ray Optics continuation video. In our previous class, we discussed about prism. We know prism is a transparent block and that is made up of glass. Here the prism consisting of three faces. One face is a rough face, that is known as base of the prism. Other two faces are polished, that is known as refracting surface of the prism. Okay. Here the angle between the two refracting faces is known as angle of the prism. Okay. Here let me see the angle of deviation produced by the prism. Okay. So far I consider a prism ABC. Here I consider the prism that is ABC. Here it is the angle of the prism. Okay. So the surface AB and AC are polished surface or refracting surface. Okay. Surface AC and AB or refracting surface or face, refracting faces. Okay, then the BC, that is a rough surface or rough face, rough face. Okay, here I consider a ray of light that is incident on the side AB, that is named as PQ. It incident at the point Q in the prism, okay, at the side of AB. At that point I drawn a normal. Here we know the ray of light traveling from rarer to denser medium, so it will bend towards the normal. Okay, then it will bend towards this side. Again it will incident on the surface AC. Here the ray of light travel from denser to rarer medium, so it will bend away from the normal. Okay, at that point I drawn a normal. Okay, here at the point Q, I consider the angle of incidence is I1 and the angle of refraction, that is R1. At that point, here the point of incident on the surface AC will be R. Okay, then the angle of incident in the surface AC, that is R2. Angle of emergent, okay, this is a angle of emergent, that is I2. The ray RS, that is a emergent ray, okay, because it is emerging out from the surface AC. Okay, here the normal on the face AB and the normal on the face AC that are intersect at a point, that is known as N. Okay, then I am extending the incident ray and then extending the emergent ray backwards. It meet at a point, that point is referred as M. Then the angle between the incident ray and the emergent ray, that is known as angle of deviation D. This is known as angle of deviation D. Okay, so we can write this angle as D1 and this angle as D2. Here at the point Q, the incident ray is deviated its path, and also at the point R, here it is an incident ray. At that point it will deviate its path as emergent ray. Okay, let me see how to calculate the angle of deviation. Okay, here we know I1 is the angle of incidence. Okay, at the face AB, and I2, sorry, this is R1. Okay, R1 is a angle of refraction at face AB. Then R2, that is the angle of incidence at the face AC, and I2. Okay, I2 is the angle of refraction at phase AC. That I2 is also known as angle of emergence. Angle of emergent. Okay. I1 and R1, that is the angle of incidence and angle of refraction at the phase AB. And R2, I2, that is the angle of incidence and angle of emergent at the phase AC. Okay. Then we know the angle between the incident ray. Okay, this is the incident ray and this is the emergent ray. The angle between the incident and the emergent ray is known as angle of deviation. Okay, the angle between the direction of incident ray, direction of the incident ray PQ and the emergent ray, that is RS, is called angle of deviation. Okay, it is denoted by the letter small d. Here I consider first of all angle of deviation at the phase AB. We need to find D1. Okay. The angle of deviation D1 at the surface AB. We know that is equal to angle RQM, that is equal to D1. Okay, we can write this D1 as C. Here this is D1. Here this is a line. Okay, this is a line. Here this is a line. Okay, these two lines are crosses at a point. So this angle is equal to this angle. Vertical opposite angles are equal. So this is I1 because of this I1. So we can write D1 as I1 minus R1. Okay, we can write D1 as I1 minus R1. Okay, then angle of deviation D2 at the phase AC, this D2. Okay, angle of deviation D2 at surface AC. Okay, that is written as QRM, that is equal to D2. We can write in the same manner as D2 is equal to I2 minus R2. I2 minus R2. Then the total angle of deviation, that is the angle between the incident and emergent ray. Okay, total angle of deviation. Total angle of deviation, that is D. D is equal to, we can write D as I2 minus D1 plus D2. Okay, because see here this is a part, we know this is M, this is Q, this is R. Okay, here it is D1, here it is D2, here it is D. We can write this angle as 180 minus D. Okay, we know summation of a angle in a triangle will be 180 degree. Then 180 degree is equal to, this is 180 minus D, then plus D1 plus D2. After solving this we get D is equal to D1 plus D2. Okay, we get D is equal to D1 plus D2. We get D is equal to D1 plus D2. We know very well D1 is equal to I1 minus R1 and D2 is equal to I2 minus R2. Substitute in the above expression, then we get the angle of deviation D is equal to I1 minus R1 plus I2 minus R2. Okay, then rearranging this, then we get I1 plus I2 plus R1, this one minus R1 minus R2. Okay, after solving this, then we get I1 plus I2 minus R1 plus R2. Okay, this is the equation for angle of deviation. Okay, angle of deviation in the prism. Then here I consider a quadrilateral. Okay, quadrilateral, that is AQNR. See, here I consider a quadrilateral, that is AQNR. Okay, here I draw that. AQNR. We know this is 90 degree, this also 90 degree. Here it is a angle of the prism A. This angle that can be written as QNR. We know the summation of the angle inside the quadrilateral will be 360 degree. That is equal to angle A plus 90 plus 90, 180 degree, plus this angle can be written as angle QNR. Okay, then next I considering a triangle QNR. Okay, this part N, this one is R. Okay, here we know this is R1, this is R2. So we can write summation of the triangle will be 180 degree, then QNR plus R1 plus R2 is equal to 180 degree. Okay, so we can write this, we can compare these two equations. Okay, this equation became 180 degree is equal to A plus QNR. Okay, then we know QNR, see, QNR, this QNR and 180 degree. Substitute in this expression, then we get finally that is R1 plus R2 is equal to A. Okay, we get final expression, that is R1 plus R2 is equal to angle A. Substitute this equation in this equation. Okay, D is equal to I1 plus I2 minus R1 plus R2. Then we get D as D is equal to I1 plus I2. Then this one became minus R1 plus R2. Okay, then we get D is equal to I1 plus I2 minus A. This is the expression for angle of deviation. Here this angle of deviation that depends on angle of incidence, angle of emergence and the angle of the prism. Okay, for a given angle of incidence, for a given value of I, here the angle of emergent that will be decided only by the refractive index of the material of the prism. Okay, see, angle of minimum deviation, angle of deviation, here it is represented by the symbol small d. Okay, the angle of deviation is an angle between the extended incident ray and the emergent ray. Okay, that is denoted by as d. Then the d is equal to d1 plus d2. Okay, so we need to find d1 and d2. Here we can find d1 at the surface AB and d2 at the surface AC. Okay, d1 is equal to I1 minus R1 and the value dt is equal to I2 minus R2. Okay, then substitute in that expression, then we get final value of d. Then I can say a quadrilateral, that is AQNR. We know the sum of the angle in a quadrilateral will be 360 degree. We can write 360 is equal to A plus 180 plus angle QNR. And I consider a triangle, that is QNR sum of the triangle will be 180 degree, then 180 degree is equal to r1 plus r2 plus qn angle qnr. Okay, in comparing these two, then we get d is equal to, then we get r1 plus r2 is equal to a, substitute in that expression, then we get d is equal to I1 plus I2 minus a. Okay, here the angle of deviation depends on angle of incidence, angle of emergent and angle of the prism. Okay, and it also depends on, this I2 depends on refractive index of the metal of the prism. Then our next topic, that is angle of minimum deviation. Our next topic, that is angle of minimum deviation. Here it is represented as capital D. Angle of deviation is small d, that is d is equal to I1 plus I2 minus a. Here we find the angle of minimum deviation, that is d. Okay, here I consider a graph between angle of incidence and angle of deviation. Okay, always the applying term is in x-axis and getting term in y-axis. Here angle of incidence is in x-axis. Okay, here angle of deviation, that is small d. Okay, 20 degree, 40 degree, 60 degree, then 80 degree. Here 40 degree, 50 degree, then 60 degree. Okay, if from the observation, okay, from the observation we found that the angle of deviation, okay, the value of d decreases with increase in angle of incidence, that is I1. Okay, decreases with increase in angle of incidence. Okay, it come like that. See, the angle of deviation decreases with increase in angle of incidence. Okay, and a particular minimum value, it reaches a minimum value, that value is known as d. Okay, at that minimum value, angle of incidence is equal to angle of emergent. Okay, after reaching that value, it will increases the value. Okay, see, if the angle of incidence increases, the angle of deviation decreases, it attain a minimum value. Okay, that is known as d, angle of minimum deviation. Okay, after that it will increases. Okay, this is known as angle of deviation. At a minimum deviation, first thing is the angle of incidence is equal to angle of emergent. Okay, then the second thing appeared is the angle of refraction in the first phase is equal to angle of incident in the second phase. I1 is equal to R2. Okay, then the third thing, that is the refracted ray. Okay, the refracted ray inside the prism, that is travel parallel to the base of the prism. Refracted ray inside the prism, that is parallel to the base of the prism. Okay, see, at angle of minimum deviation, at first thing is angle of incidence is equal to angle of emergent, I1, that is equal to I2. Second thing, that is at the minimum deviation, the angle of refraction in the first surface is equal to angle of incident in the second surface, AC. R1 is equal to R2. Then the third one, the refracted ray inside the prism. Okay, this ray QR, that is parallel to the base of the prism. Okay, these are the three things will be observed at the angle of minimum deviation, capital D. Okay, then our next topic, refractive index of the material of the prism. Okay, we know at a minimum deviation, at a minimum deviation capital D, angle of incidence I1 is equal to angle of emergent. Okay, we can consider this one as I. And second thing, that is angle of refraction in the first medium is equal to angle of incidence in the second medium, that is equal to, we consider this one as R. Okay, at that situation we know the angle of deviation, that is D, is equal to I1 plus I2 minus A. Okay, here at D, then D is equal to I1 plus I2, then we can write this one as I plus I minus A. Okay, then D is equal to 2I minus A, correct? Then we can write I is equal to A plus D by 2. Then one more thing we know, R1 plus R2 is equal to A. We know R1 and R2 are same, then we can write 2R is equal to A, then R is equal to A by 2. Okay, here refraction is possible at the surface, so we can apply Snell's law. Okay, apply Snell's law. That is, refractive index of the material of the prism N is equal to sin I by sin R. Okay, refractive index of the material of the prism is equal to sin I by sin R. We know sin I is equal to A plus D by 2 by sin R is equal to A by 2. Okay, using this expression we can find the refractive index of the prism. Okay, by knowing the angle of incidence and by knowing the angle of deviation. This is one of the experiment in your 12th standard. Okay, this is a practical from the lesson ray optics. Okay, thank you.